As I mentioned in the previous video, the rules for figuring out what gets called in a dynamic method selection situation are actually pretty simple. Now, our intuition as humans sometimes leads us astray, where we start looking for patterns or assuming the Java language is going to do something that somehow seems more sensible than the simple thing. Okay? So I have an example here which illustrates a situation where I made a mistake when I was first learning Java, and there's a strong chance that you may as well. Okay? So your job, and this one's going to take a little while to figure out what the question even is, but your job is to figure out what the result of this code running down here is. And so let me talk about the background of this problem. We have an interface called animal, and it provides a greet animal, sniff animal, and flatter animal method. And all these are default methods. And I've kind of cheated here. I got rid of system.out because I wanted everything to fit on the slide. But so I've omitted a little bit of unnecessary Java syntax. I think the concept is still clear. And then over here, I have a class called dog, which implements animal. It provides a sniff animal and a flatter dog method. And your job is to figure out what will happen when I get down here and run this code. So what do I have? Well, I have two variables. I have animal, A, and dog, D. So the static types are animal and dog for A and D, respectively. Now, they're both set equal to a new dog. And so the dynamic type of the objects that A and D point to are both dog. And then we have a series of invocations, 3 of which use a variable which has static type animal, and 1 which has static type dog. And then on the other side, it's all static type dog. Okay, so now think about what you think each of these lines will do. And this is a really important puzzle. So if you're watching this at home, really try to come up with an answer and think hard about it, and then compare your answer to what I do. And hopefully you'll make the same mistake that I hope you will. Or better yet, no mistake at all. We'll see. All right, let's start with a.greetD. So what happens here is we have a variable of type animal. And so we look and we say, is there a greet method that can accommodate a variable of type dog? Well, the answer is actually yes. And the argument here is that a dog is an animal. So it can fit in this animal box, no problem. So we get hello animal when that line runs. Next is a.sniffd. Okay, so a.sniffd, what happens here? Well, Java says, is there a method that can handle a dog? Well, yeah, there it is, sniff animal A. So a dog is an animal, so it can call this method, but through the magic of dynamic method selection, because dog also provides a sniff animal A method, this is an overwriting of the original sniff, and so we get dog sniff animal. Now that happens even though there is not an override tag, right? That was optional, as I noted, but in 61B you should always have an override tag. All right, now let's try and get a dog to flatter a dog. What happens here? Well, Java says, hey dog, do you have a method that can flatter dogs? Well, yes, okay, in this case, D flatter dog, it will call this method and we'll get you are cool dog. And then finally we have a.flatterd. So in this case, Java says animal. Do you have a method called flatter that can handle a dog? Yes, okay, here it is. And then some of you might have thought, okay, well, dog has a better one, and so it should be you are cool dog because this is more specific. But actually, the correct answer is you are cool animal. And so for those of you who made this particular mistake, and even when I was talking to my TAs recently, I gave them a similar puzzle, and they were like, what? So this is a very easy error to make unless you're thinking carefully. This seems scary maybe to some of you, but it turns out the answer is pretty simple. The answer is that if we look at flatter animal and flatter dog, these do not have the same signature. And the way we defined overriding, and this is the most important point, the way we defined overriding is you have to have the exact same signature, and these are not the same. Animal is not the same as dog, okay? So this is an example of overloading and not overriding. Now, an alternate way of thinking about this is something I call the method selection algorithm, okay? And this is just something like I've thought about. And I've seen this approach also helpful for explaining this to students. Okay, so this is going to seem a little jargony, but we'll relate it to the problem we just did. So let's consider a function call that goes like this. Foo is the invoking variable or expression or whatever, dot bar, where bar is the name of the method, and we take in a variable x1. Let's say that foo has static type t prime, and x1 has static type t1. So what happens is at compile time, the compiler needs to make sure that everything's okay. It's a weird signal. My hands. This is okay now, apparently. All right. Anyway, at compile time, the compiler verifies that t prime has a method that can handle t1. Just like here, we ask, does animal have something that can handle dog? Okay. So what it does is, after finding something that matches, it will record the signature of that method. Okay. And it writes that down somewhere. So it says the method that we need to call is something in animal something that has the signature flatter animal. So it records this signature, flatter animal. Okay. Now, one little side note that I'm going to mention is if there are actually multiple methods that can handle T1, the compiler will pick the most specific one. That didn't apply in our little example here, but the study guide has questions like that. But for example, if the type was dog, and t prime, in this case animal, had both a flatter dog and a flatter animal method, it would pick the dog version because that's the more specific one. But we don't have such a method here. Okay, kind of an aside though. And so then at runtime, if foo's dynamic type, so in other words, A's dynamic type, which is dog, if it overrides that recorded signature, which was flatter animal A, then we'll use the overridden method. Now here, dog does not override flatter animal A, and so as a result, we end up just using t prime's version of the method. So this is the algorithm view of that. If you didn't like this very short explanation, here's a longer one, but they're tantamount to each other. Okay. So just to look at this visually one last time then, whenever this code is compiled, the compiler says, is there a method in animal that can handle dog objects? Yes, right? So, well, in that case, what is that method called? It's called flatter animal A. So it writes it down in some ledger book. And then later when the code actually runs, it has to use a method with that exact signature because that's what overriding is all about. Okay. So I hope that helps, and definitely check out the study guide. This is something which students find frustrating at first, but once you do the right kind of problems and you develop the right intuition, the rule is really quite simple. It just basically boils down to this slide.